So this chapter actually consists of 3 main subtopic, 7.1, 7.2 and 7.3. Kuat ni. Kita sekejap kot. Okay, so 7.1. Adakah kamu terganggu dengan bunyi itu? Kau okey je?
Bunyi apa sih?
Tak ada dengar apa ni?
Tak.
Okay, tak ada, okey lah. Okay, so bunyi aircon tu bunyi kuat. Bagi saya kuat lah. Saya tak tahu lah kamu dengar ke tak. Tak dengar bagus lah. At the end of this topic, students should be able to learn about force, field strength, then we also have potential energy, and then satellite motion. Okay, and today we're gonna focus on these two only. These two quantities lah, force and gravitational field strength, which is subtopic 7.1. So potential energy, maybe we'll learn it tomorrow. It's a little bit different compared to the previous, right? I know you learn in chapter 5, U is equals to mgh, right? But that one is potential energy when you are on the surface of the earth, okay? But this time we consider what happened when we go further from the surface lah. And then we'll learn about satellite motion as well at the end of this chapter. So these three, especially the last one, is not really related to the other two. Yang dua ni memang dia related, but then these three dia pakai formula berbeza, and this one memang a bit unrelated. So once you get the question, kamu tahulah dia part yang mana. Okay, yang the good news pasal chapter ni, dia punya formula memang senang sangat, substitute je, and most of it is this one is vector quantity, dua ni is a vector quantity, and these two most likely will involve scalar quantity. So senang sikit lah. Yang vector quantity pun tak adalah susah, because this one is basically just a force and field strength. And then tak adalah bad news kan, I mean the only downside is kamu ada beberapa formula lah, ada quite a few formula. So if you want to refer to your formula sheet, actually you have your formula sheet dekat dalam drive tu tau. Kalau kamu buka drive kamu, dia dekat dalam nota bahan PDP tu kan, and then dia under the, kamu pernah tengok tak formula sheet ni?
NASA.
Ada, okay, so that's good lah. So dia actually under folder 0, and then dia ada file intro, and inside there ada formula sheet. So formula sheet ni kamu boleh start biasakan lah. I strongly suggest kamu untuk bahagikan. Macam contohnya formula ni daripada mana ke mana. Contoh saya try buka. Apa saya nak buat lupa. Okay. Try to find the formula sheet. Try to find it. Present. Okay, can you guys see this, what I'm showing over here? Boleh nampak tak list of formula tu?
Nampak sir.
Okay, nampak ya? Okay, so actually can divide into each topic lah. Contohnya chapter 1, equation 1 and 2 macam tu. And then kamu draw a line lah. And then chapter 2, equation 3, 4, 5, 6. And then chapter 3, 7, 8, 9. Nanti kamu boleh bagikan lah. Kamu tengok balik kamu punya learning outcomes, and then you can divide. And biasakan pakai formula sheet ni, especially bila kira dalam tutorial, when you try to do the pasir, so that nanti kamu dah biasa. So ini contohnya, kalau untuk chapter ni, kita ada equation 18. So, I'm going to write it down. Equation 18 sampai equation 23. Okay. So, for the first subtopic, we covered equation 18 and 19. Jadi, saya tunjuk balik apa yang saya tulis ni. And then, subtopic 7.2 is equation 20. And then satellite motion, we have 21 until 23. Okay. Later on, you can refer back to this one. Now, I'm going to share back my screen on my iPad. Manakah dia? Sekejap saya cari. Okay. So, kalau kamu chapter ni sebenarnya dia punya key criteria is that you can divide in, as long as you can divide into which equation you want to use, then you should be okay. So basically bila dapat soalan tu kan, kamu tengok dia tanya apa, kamu tulis siap soal equation dia apa. Contohnya kalau dia tanya force, kamu pakai equation 18. Kalau dia tanya gravitation field strength, kamu pakai equation 19 contohnya lah. And then potential energy equation 20. So senang. So yang confusing sedikit nanti dekat bawah ni, tapi kalau kamu boleh bezakan yang 3 atas ni, yang last tak ada masalah. Itu trick untuk score this chapter lah. Sebenarnya ini antara chapter yang boleh score. So far ada soalan? Any question?
Tak ada.
Tak ada. Okay, so about 7.1, you learn about gravitation field strength, force and field strength. Okay, first of all, you guys need to understand about Newton's laws of gravitation. Okay, Newton law of gravitation, siapa boleh beritahu apa dia? Dia cakap apa? Newton cakap apa? Can somebody tell me, please? Okay, Amina tak dapat join, sure. Nanti Amina, minta tolong Amina kasih saya apa ni? MC.
Okay.
Okay, Newton's laws of gravitation. Cuba tengok nota kamu.
A magnitude of an attractive force between 2 point masses is directly proportional to ke?
Apa? Nisha, sorry, ulang balik. Laju sangat.
Panjang.
Tak apa, it's okay.
A magnitude of an attractive force between 2 point masses is directly proportional to the product of their masses and inversely proportional to the square of the distance between them.
Okay, good, very good. Memang itu dia punya laws of gravitation, memang ada state macam tu. Saya ada cara senang je nak hafal. Sekarang ni kamu dah tak perlu hafal kot. So, kalau dia tanya pun dia tanya dalam UPS. So kalau UPS, maybe kamu kena tahulah apa itu Newton law of gravitation. So yang keyword dia, saya tulis keyword dia. Number 1 is the attractive force. Between 2 point mass. Dia ada cakap 2 point mass lah? Ke tak ada?
Ada, sir.
Ada. Dia memang sebut kan 2 point masses kan. Okay, 2 point masses ni maksudnya kalau kita ada objek, katakan kamu ada apa depan mata kamu, maybe ada laptop. Right. So laptop ni kalau ikut logik, mass dia ni dia ada distribution. Kan dia bukanlah dia berat dia seimbang lah kat sini. Okay, kalau kamu ada ball, maybe berat dia pun berat kat tengah, something like that. Tapi bila kita cakap pasal point mass, kita consider mass tu sebagai satu point je. Regardless of the size of the object, we consider all the masses is right in the middle of the mass. So itu konsep yang pertama lah. So contohnya kalau kamu ada bumi kan, kalau dia kata point mass, dia consider berat tu dekat tengah-tengah. Itu konsep yang pertama lah. Okay, and then dia kata attractive force between 2 point mass. So as long as you have 2 object yang ada mass, katakan this is my M1 and this is my M2, dua-dua ada mass, and this one as long as dia ada dua mass, dia akan ada attractive force. Kalau attractive force, direction dia ke mana? Kalau contohnya dekat M ni, so dekat sini F dekat M daripada M, F on M by M. Dia dulu pakai 1-2 M1, M2, but now dia pakai symbol small m and capital M to differentiate between a large object and small object, something like that lah. So I just use the one that we use in your formula sheet lah. Okay, ini maksudnya force ni acting on mass M yang kecil ni by mass M besar. So direction dia ke mana? Kiri, kanan atau bawah? Dia attractive force. So, cuba bayangkan attractive force antara dua mass. So ke mana direction dia?
Dia macam magnet.
Yes, betul macam magnet. So ke mana? Atas, bawah, kiri, kanan untuk dekat point sini.
M kecil ke kanan,
Okay, M kecil ke kanan, very good.
M besar ke kiri.
Yes, very good. Nampak? Tak ni pula. Tak sama rata tak? Okay. So M besar tadi ke kiri. Okay. So kalau M besar ni kita tulis F dekat M besar daripada M kecil, something like that lah. I mean that one is just a subscript. Okay, subscript ni macam nama dia je lah. Kalau kamu terbalik pun tak ada masalah. Sometimes certain book dia pakai yang terbalik. Saya pakai yang biasa buku international pakai lah, yang common. So itu biasa dia guna. Okay, anyway, so kita ada attractive force which is attractive towards one another. So you can see here these two force actually opposite in direction. Satu ke kanan, satu ke kiri. How about the magnitude? Magnitude dia sama ke tak? Is it the equal magnitude or is it different magnitude?
Different.
Dia sebenarnya adalah equal. So one of the key thing here, dia memang susah sikit kalau kita fikir logik, tak logik sangat kan, tapi dia sebabnya force ni dia terbentuk bila ada dua mass ni. So cara nak kira force ni, dia ada formula. Dia F, tak kisahlah M kecil M besar ataupun F M besar M kecil, I just put the F is actually equals to G M kecil M besar over R square. Okay, so kalau kamu nak kira M kecil M besar punya force, dia macam ni. Kalau kamu nak kira M besar M kecil, dia terbalikkan je benda ni. So by then dia punya magnitude still the same sebab dia adalah product of their masses. So this is the key thing here, is that the magnitude of the force is equal walaupun mass dia sangat-sangat berbeza. Let's say kalau kamu ada bumi kat sini, lepas tu kamu ada satellite dekat sini, macam saiz kecil kan, katakanlah kamu ada bumi and satellite kan. So basically satellite tu tarik bumi sama kuat dengan bumi tarik satellite. It doesn't make much sense, tapi nanti kita akan tengoklah lepas ni kenapa dia macam tu and why it actually makes sense. Tapi saya nak kamu faham yang F ni adalah equal magnitude. Faham ke tak? So far okay?
Okay, sir.
Okay. So lepas tu Newton dia ada cakap, okay, it is actually directly proportional to the product of their masses. Okay. It is because of this equation. Okay. So this is the general equation. It's valid for all object that has a mass. Okay. Apa-apa objek yang ada mass, dia boleh guna equation ni. So this is a universal law lah. Tak kisahlah objek tu kecil ke besar. So dia kata F is directly proportional to their masses. Okay. And then inversely proportional, and force also inversely proportional to the R square, to the distance between of the two objects. So I'm going to bring this one a little bit up here. So because we consider this one as a point mass, kan? So the center of the mass is over there, the center of the mass is over there. So basically the distance should be from center to center. Ya, ini antara satu kriteria penting lagi lah. Dia punya distance, R dia tu center to center. Tak kisahlah shape of the object tu macam mana, dia always from center to center. Okay. And then the G here is basically just a constant lah. Dia macam kalau kamu ada linear punya graph kan, so dia mesti ada constant. So this is the constant G. So the G values is actually equals to 6.67 times 10 negative 11. Betul tak? I think it's correct. The unit would be, saya check unit m square kg minus 2. M square kg minus 2. Okay. Most of the time you don't have to write down the unit pun. But then the unit tu ada dalam list of selected constant. Okay. So according to Newton's, dia kata any two object yang ada mass ada attractive force. So katakanlah kamu dekat dalam bilik tidur kamu kan, example 1. So you're basically standing in front of your table. And then kamu ada bed on the other side of the room. Okay, kalau according to Newton, basically kamu ada mass 1 and mass 2. Agree ke tak? Adakah kamu akan ada attractive force between those two? Apa kamu punya opinion? You have two mass. Do you have attractive force between those two?
No.
No. Okay. Lagi lain?
Tak ada.
Tak ada. So maksudnya Newton ni menipu. So sebenarnya Newton punya law ni, dia universal law ni tak banyak tau. So one of the universal law is gravitation universal law lah. Tapi kita tak panggil universal law. Tapi certain international book dia panggil universal law. So maksudnya dia memang valid untuk any object, any size. Okay, mass kecil ke mass besar, dia ada. So sebenarnya kamu ada attractive force between the two masses. So M dan M. So ada. So saya cakap ada lah, memang ada. Memang Newton cakap ada, saya cakap ada. So kamu kena terima lah dia ada. Jadi kita akan kira berapa force dia. Okay, soalan saya yang seterusnya, katakanlah kamu ada force. Dua attractive force. So apa yang, adakah kalau kamu duduk ataupun kamu berdiri lama-lama dekat sini, eventually adakah kamu akan tertarik? I mean, adakah katil tu akan bergerak ke kamu dan kamu bergerak ke katil? Bukan berjalan lah, I mean dia bergerak, tertarik. Kamu rasa? Faham tak soalan saya ni? Adakah kamu akan drag towards the bed?
Lepas tu tidur. Kalau ngantuk.
Itu kamu berjalan. Tak, maksud saya kalau without kamu berjalan, just standing over there, with time, adakah kamu akan rapat dan kemudian tertidur. Bertemu. Adakah dia make sense? Adakah dia masuk akal? Logik terima? Yes ke no?
No.
No. Okay, kenapa no?
Sebab macam mana boleh bergerak?
Kenapa dia boleh bergerak pula? Ada force? Force ni memang wujud. Okay, cuma kenapa kamu tak bergerak? Cuba fikirkan. Nanti jadi kita bincang kot. Jadi kita tengok. And then maybe kita boleh fikirkan kenapa dia tak bertemu. Okay, anyway. First thing first, we try to calculate kita punya force tu. Okay, katakanlah mass of the bed. Let's say I put here about berapa kilo 15 kilogram. Ringan je kata. Mass of the person, let's say, okay, maybe saya change the PM ni. Oops. I put small m over here and capital M over there. Okay, katakan mass of Arif. Arif ada Arif? Arif?
Ada sir.
Sekejap. Arif ada dua orang ke Arif? Oh betul, seorang lagi ambil. Okay Arif, berapa berat kamu? Kita cuba je example. Kita buat kiraan.
Sekejap, berat.
Lebih kurang ke?
40 something kali
Ya.
tahir.
Dahsyat. 40 something. Okay, let's say I put 45. Just put 45. Okay, dulu saya pernah 45 dulu lah. Sekarang ni dah berlalu pergi. Okay, anyway, you have two mass. Satu daripada person, satu lagi daripada bed. According to Newton, you will have attractive force towards one another. The magnitude is the same, but the direction will be opposite. So we try to calculate the force in magnitude. So F would be equals to G small m, capital M. Tak kisahlah turutannya, doesn't really matter pun. Katakan the distance between you and that bed is maybe 2 meter. Because we're sitting inside the same room, right? So it will be 6.67 times 10 to the power of negative 11 multiply with 45 multiply with 15. Okay, saya terbalik doesn't really matter pun. Divided by 2 square. Can somebody press the calculator for me and give me the answer? Berapa dapat? Saya tak nak tekan calculator. Untuk kamu tekan.
1.125.
Oh, bagaimana? 1 point?
126 darat 10 negatif 8.
Darat 10 negatif
8.
8. Okay, thank you. Okay, yang lain dapat the same answer or you get a different answer?
Dapat sir.
Okay, dapat.
Sama.
Okay, good. So now I want to ask you guys, in your opinions, is this a big number or is it a small number? Small. Yeah, it's to the power of negative 8. Before this, kalau chapter 4 tu, kalau kamu nak gerakkan objek, maybe you apply about 100 Newton punya force. So this one is to the power of negative 8. So very small. Tapi ada. So, as long as dia ada force, adakah dia still akan bertemu? Okay, fikirkan dulu. Jadi kita jawab. So nak tahu kekuatan, how do you know that this one is big or small number? Actually, if you just imagine dia punya force, kamu tak boleh nampak pergerakan tu. Force tu kamu boleh felt, boleh rasa, tapi kamu tak nampak. So if you want to see something, actually you want to see the motion. So you know that F is equals to apa sebenarnya? Ingat tak chapter 4? F equals to apa? Yes. E itu apa?
Acceleration, boleh jadi gravity.
So A here is actually the acceleration. Okay. it shows how fast the person ataupun the object moves towards one another. Berapa banyak acceleration dia undergoes, baru kamu nampak dia small number ke big number, macam ni lah. So sama ada dia bergerak ke tak, sebenarnya you have to use this one. So this one, kalau dalam chapter ni, yang A here is what we call the gravitational field strength. Okay. Kalau dekat previous chapter, contohnya chapter 2, we use G. That one is constant lah, because we assume that everything is on the surface of the earth. Okay, tapi now we want to consider kalau dia dekat outer space ke, kalau dia further away. So we consider that one as A. Cuma saya nak tekankan, dia panggil benda ni sebagai strength. So student, bila dia nampak strength dalam exam, dia kata calculate the gravitational field strength, the first thing that student terfikir is the force. Bukan force is force, strength is A. Ingat tu. So dalam exam, if they ask you to calculate something, most likely they will give you in sentence. Macam ni lah, calculate the gravitational field strength. So some student they got confused because of the word strength. Dia ingatkan strength tu adalah force, tapi no, strength actually represent the A. So I can rearrange this equation, so I can get that A here is equals to F over M. So if I want to use the gravitational field strength tadi punya formula, gravitational punya Newton gravitational law, GMM over R12, that I have to divide with M at the square. So 1 tu ni tak ada dalam nota kamu, tak ada, selesai padam. Dulu ada, sekarang tak ada. So you get GM over R square. So this is the equation that represent the gravitational field strength of certain object. Okay, the question is, kamu nak pakai mass yang mana? Okay, so if you just want to use this formula, okay, so let's say kamu dalam exam kan kata calculate the gravitational field strength of the earth, mass ni kena pakai mass of the earth. Okay, so the mass is the pulling, is the one that is pulling lah. So A, if you want to calculate A, the mass would be source of gravity. Okay, sebab sometimes student got confused lah, sebab di dalam exam dia kasih certain mass, macam dia ada kasih mass bulan, dia kasih mass bumi, dia kasih mass satellite in the same question. So if you want to calculate the gravitational field strength of the earth, pakai mass of the earth. Okay, okay, now back to our situation now, here, over here. Okay, we're still going to use the same example, but now we want to calculate the values of A. So I'm going to take the diagram, this diagram. I put it over here. Okay, so this is, I put this one as example 2. This is the same example, just a follow-up question. Okay, if I want to calculate the acceleration of this person, okay, acceleration of the person. So it will be F equals to M A. Tapi mass ni kita nak pakai mass apa? Mass person ke mass bed?
Person.
Yes, mass person. Okay, so mass of the person A. So A, F tadi kita dah ada, which is 1.13 times 10 negative 8. Divided by the mass of the person, which is 45. Okay, So maybe somebody can calculate this one, and at the same time I try to calculate the acceleration of bed. Okay, so this one berapa? How much you get for the person?
2.5 point.
Berapa? Berapa? Sorry.
2.51
Okay.
darab 10 negatif 10.
Okay. Others? Did you get the same answer?
Sama sir.
Okay. How about the bed?
7.53 darab 10 negatif 10.
Okay. So you can see here, by logic, lighter object will have higher acceleration, right? If you apply the same force lah. But still, sorry, negative 10 kan? But still, this is a very small number. 2.51 times 10 negative 10 dengan 7.53 times 10 negative 10 is very small number lah. Tapi, this still ada direction. So, force tadi, satu tu ke kanan, satu tadi ke kiri. Acceleration pun sama lah. Satu ke kanan, satu lagi ke kiri. So, now back to my question. Kamu akan bertemu ke tidak by itself? Kalau kamu duduk, diam, bertahun, adakah kamu akan bercantum?
Tak.
Kenapa? Tak is a correct answer lah. Tak pernah pula kamu duduk, tiba melekat kat dinding kat rumah. Tak ada kan? So, kenapa benda tu tak berlaku? Cuba fikir balik chapter 4. Ada satu benda.
Sebab kita ada force lain that acts upon us.
Contoh?
Normal force.
Lagi?
Weight.
Lagi?
Gravity yang biasa, yang downwards.
Okay, apa force yang elakkan kita bergerak?
Frictional force.
Yes. So, actually, setiap daripada kita ni, obviously kita ada static frictional force, right? So, setakat force yang kecil macam tu compared to the static frictional force, dia tak bergerak pun. Sebab apa? Frictional force tu prevent dia daripada bergerak. So, that's why you never sees, you will never encounter this problem lah. Tak pernah kamu duduk-duduk, tiba-tiba bed tu melekat kat kamu melekat kat bed tu mungkin lah kan. So, that's the idea. Tapi, force tu wujud. Even though small, the force is there. Okay, so this is the beauty of Newton Universal Gravitation Law lah. It varies for all objects, regardless of whether it's big or small, it doesn't matter. It obeys this law. Okay, any question? Ada soalan?
Tak ada sir.
Okay, so basically you learn few things today. Yang pertama sekali, you have two formulas that you learn. Okay, saya simpulkan sikit apa yang kamu belajar today. Dan lagi kita buat latihan. But before that, saya just simpulkan the two formulas. So you have force of gravity, which is equals to F G M over R square. Okay. And then you learn about gravitational field strength. Okay, and the formula would be A, dia tak pakai G pun, A equals to G M over R square. Okay, these two is a vector. It's a vector quantity. So by right, you should write the direction lah. Vector. And then normally, because the question doesn't give you any diagram, normally it doesn't give you any diagram. So when you try to answer the direction of force, normally we state, okay, direction of force of the moon is towards the earth. Macam tu lah, something like that. Macam kamu gambarkan dia ke arah objek yang lagi satu. So ada attractive force. Okay. So itu biasanya. Kalau kamu lukis, you can state whether it is to the right or to the left lah. Kalau kamu lukis dalam jawapan kamu kan. Then find the answer, you can simply state the force is to the left, the force is to the right, something like that. Okay, the unit here would be Newton. Okay, over here the unit would be ms minus 2. Okay, before we try to do any calculation on tutorial, saya nak sentuh satu benda lagi, which is about the relation. Okay. Okay, so kalau kamu perasan, ni tadi kata the magnitude of the force is inversely proportional to the r square, kan? So that one is another key thing. Okay, so I'm going to draw a graph. This is the axis of the graph. Maybe I have to bring this one to the right a bit. Okay, and then I'm going to draw the Earth ataupun any planets. Okay, tapi saya nak ingatkan yang most of the time question kamu, dia akan involve objek yang ada mass yang besar lah. Sebab masa tu baru kamu nampak dia punya effects of the force tu. Macam kalau setakat person tadi, dia tak nampak sangat kan. Besar sangat tak? Okay, good. Okay, so this one is the axis of A, which is ms minus 2, and this one is the radius. Okay, so if you guys still remember, the formula A is equals to gm over r square. Okay, this equation only valid from the surface of the earth to the outer region. Okay, so over here the relation is A inversely proportional to the r square, because this two is a constant. Mass of the earth, katakan ini bumi, let's say di bumi, there could be any planet, but let's say this is earth. As long as this one doesn't change, then that means the gm punya value doesn't change. The only value that changing is r. Okay, saying it. Nampak, tak boleh bawa. Nampak? Okay. Okay, better tu. So, kalau kamu nak lukis graph dia, graph bentuk apa ni? Kalau 1/r square. You can tell me. It's a quadratic, it's inverse. Something like that. Okay, and in fact, it goes, as it goes further, it goes towards the 0. But still, it's not approaching 0 lah. Sebab apa? Dia tak boleh 0. Sebab it doesn't matter how big this one will become very very small and approaching 0 lah. Tapi dia tak sampai 0 pun. 1 over x, dia tak boleh 0. So basically, this one after radius of the earth. Okay, on the surface of the earth itself, dekat atas bumi ni, berapa nilai dia? Gravitation field strength. Berapa value dia? Siapa tahu? Guys, are you there?
Tak ingat.
Berapa? gravitational field strength on the surface of the earth? A dekat atas bumi berapa?
9.81.
Yes, very good. So 9.81. Okay. So 9.81 here represent the acceleration on the earth. So macam mana nak dapat nilai ni? Katakan kamu substitute nilai R ni dengan radius of the earth. Radius of the earth ni constant. Mass of the earth pun constant juga. Kalau kamu substitute dalam ni, kamu akan dapat 9.81 something lah. Tapi kita anggap dia 9.81. Kita bundakan dia sebagai 9.81. Okay. And then before this, if it is inside the surface of the earth, you get a straight line. Okay, yang straight line ni dia dah keluar daripada syllabus kamu, dia punya formula. Tapi ada dalam nota kamu, you can refer how they derive to get this part. Okay, but you still need to know the punya relation. The relation here is A directly proportional with the R. Okay, understand? So kalau dia after this, dia adalah inversely proportional. Tapi dekat sini dia adalah directly proportional. You don't have to know the formula, tapi kamu kena tahu relation. Ni relation, so kamu kena tahulah A is directly proportional to R if you are considering the mass inside the earth. Sebab apa? Mass dia berkurang bila kita makin dalam. Sebab tu dia punya gravitation field strength pun berkurang. Kalau makin jauh, obviously dia berkurang lah. Okay, any question? Guys, do you have any question?
No, sir.
Okay. So kalau tak ada soalan, maybe we can try to do one example. We try to do the simple one. Saya nak buat force tu, tapi force tu panjang sikit. So saya rasa maybe kita boleh buat gravitational field strength dulu. We're going to try question number 7. You are on an airplane traveling with constant velocity. Okay. What is the gravitational field strength at that altitude, given that the mass of the airplane is 1.5 times 10 to the power of 4? Okay, dia kata, saya rasa dia ada beri nilai constant tu kat sini. So dalam exam, kalau dia tak beri dekat formula sheet, dia akan beri dekat soalan. So you don't have to memorize anything lah. Numbers ni tak perlu hafal. Okay, so first thing first, once you get the question, you try to highlight. Airplane traveling constant velocity, altitude of 20,000 meters from the Earth's surface. What is the gravitational field strength at the altitude, given that the mass of the airplane is 1.5 times 10 to the power of 4 kilogram? Okay. Tukisan, how do you want to draw this one? Kamu ada Earth kan? This is your Earth. Okay. And then you have the aeroplane over here. Okay, they give you the altitude. Altitude ni distance from where to where?
From plane to Earth.
Macam mana? Altitude of 20,000. Cuba. So dia daripada mana ke mana? Adakah dia daripada center ataupun daripada surface ke aeroplane? 20,000 tu.
Surface ke aeroplane.
Yes. Okay, so altitude. Okay, remember altitude ni dia represent jarak daripada surface of the earth. Okay, sometimes dia tak kata pun yang ni, dia tak sebut pun yang this one. Tapi it's a well-known quantity lah. Yang altitude ni represent distance from the surface. Okay, remember that. So this is what we call the altitude. Okay, which is equivalent to 20,000 meter. Okay, good, very good. Okay, what is the gravitational field strength at the altitude? So, if you want to calculate gravitational field strength, formula apa kamu nak pakai? A, right? Okay, saya tanya, saya jawab. Okay, now, mass would be mass of apa here? Mass apa saya nak pakai dalam ni? Adakah saya nak pakai mass of the earth ataupun mass of the aeroplane? Dari satu mass ya?
Aeroplane.
Okay, apa source gravity tu? Apa gravity tu? Punca dia daripada mana? Daripada mana? Daripada aeroplane ke daripada bumi?
Bumi ke?
Bumi lah kan? So mass of apa kita nak pakai?
Bumi.
Ha?
Alright.
Apa ya? Tak dengar.
Mass bumi lah kan.
Mass bumi. Okay, mass of earth. Okay. So mass of earth. Okay, so dalam exam memang is a bit confusing lah sebab dia memang kasih dua-dua mass and then dua-dua distance macam-macam dia kasih. So that's why saya memang suka tanya lah walaupun kadang-kadang nampak simple tapi you know sometimes we get confused. Okay, and this one pula, distance from where to where? R tu jarak daripada mana ke mana? Adakah daripada jarak altitude je?
Radius tu tambah dengan altitude tu ke?
Okay, good, very good. So this one actually from center to center, remember center to center. So it will be center of the earth towards the center of the aeroplane. So aeroplane tu, I mean kalau nak center kat atas sikit lah, tapi doesn't really matter pun sebab dia kecil je. Okay, here you have to add up radius of the earth with capital R, E, with the altitude. So it will be RE tambah altitude. Okay, I hope you guys really understand sebab saya memang tunjuk sekali ya. After this, I think you can try to do the question. Shouldn't have any problem. So mass of the earth is given 6 times 10 to the power of 24. That one is under your constant. The R would be RE, which is 6.4 times 10 to the power of 6. Then you still have to add up with the 20,000. 1, 2, 3. Okay, be careful sometimes they give you in kilometer for radius of the earth. So you have to multiply with the prefix to the power of 3 lah. And this one lagi satu, make sure kamu letak square. So selalu sangat lupa square. So now, try to press your calculator. I want everyone to press your calculator sebab for some reason, students selalu salah tekan chapter ni. I don't know why. Most likely because of the square and dia kurang dia punya brackets tu tak cukup. So practice to press it from today so that with the exam you get the correct answer. Okay, berapa dapat ni?
Nilai dia besar ke sini?
9.71 is it? Betul? Okay, this one if you compare with the on the surface which is 9.81, obviously this one is a little bit smaller. So it makes sense because as you go further from the object, the gravitational field strength will decrease. So makin jauh, makin kurang. Okay, that's why eventually at one point kamu boleh escape the gravity. So that's why kamu akan ada belajar satellite motion nanti. Okay, for now, any question?